Hey everybody. We're going to look at another set of kinds of hypothesis tests. And as you can see, it's hypothesis testing with two samples. What the general idea here is that we want to make a comparison between a couple things. And just like the hypothesis tests and the confidence intervals before, there's going to be several different categories, let's say, that have their own details, but there'll be a similar pattern that will emerge. And really, it's just going to be the same as uh, the hypothesis testing we've done with single samples. We just have to kind of adjust some of our formulas for what happens with two samples. So I just want to introduce the big concept, and then we'll do a couple of videos with some examples of the different kinds of testing we'll do. So with that in mind, here's the basic idea. Let's suppose we have two random variables. I'll call them x1 and x2. And suppose we want to compare something about them. We'll generally be looking at comparing means or comparing proportions. I'm going to use means for this the general idea here, but we'll also do a similar idea with proportions. So each of these random variables will have a mean. X1, let me just change how I write this a little bit. X1 will have a mean, and X2 will have a mean. So X1, we'll call it mu1. X2 will have a mean called mu2. And if, just like with hypothesis testing, there'll be some kind of null hypothesis. Usually, we'll come back to that in a second. Usually what we're doing is, let's say we're supposing that mu1, or we want to test to see if mu1 is greater than mu2. The way we will typically write this statement is that we can rewrite this as mu1 minus mu2 is greater than 0, right? If mu1 is greater than mu2, then when you subtract mu2 from mu1, you get something greater than 0. That would be our hypothesis, right? Our alternative hypothesis. The null hypothesis, right, would be then that mu1 is less than or equal to mu2, or just equal to, depending on how you're setting it up. I'll write it this way for now. So mu1 minus mu2 is less than or equal to 0. Right? We could obviously do the same. This might be our null hypothesis, and this might be our alternative hypothesis. Right? So that's what we are generally testing for, that there's a difference between the means. And the null hypothesis will be typically that there's no difference. It doesn't have to be precisely that, but let's just think about that for now. Well, the way we might take a test, conduct a test, similar to the tests we've thought about in the past, is we go and get a sample. But in this case, we'd be getting a sample from two different distributions, x1 and x2. So let's suppose I went out and got a point sample. I'll call it x1 from the first distribution, and we get a sample from the second distribution, and we want to compare them. And we're going to compare them in the same way we compared the means up here, right? These are our sample means, and we're going to use the same comparison. So we took mu1 minus mu2. We're doing x1 bar minus x2 bar. This comparison, right? We're creating a new distribution, right? It's like all those experiments we've done where maybe we roll a dice twice, and first we roll one die, then we roll the other. Those are their own distributions, right? We've looked at the distribution of dice rolls before. But then if we decide we're going to add those dice together, we're creating a new distribution of the sum of two dice rolls. This is a similar thing. Whatever these distributions x1 and x2 are, when we take sample means and then subtract them, find their difference, we're creating a new sampling distribution. Okay, and this sampling distribution, I'm going to call it D as like the difference distribution. The mean of this distribution should be equal to the mean of the difference of the original distributions, right? So if it turns out there is no difference, then the mean would be 0. And if it turns out that there is a difference, then the mean would be depending on what that difference is, okay? So that's the first part of the setup. Now remember, when we did hypothesis tests with single means, we would sometimes use a z-score for our test statistic. Sometimes we use a t-score. So depending on the details of the situation, do we know the standard deviation of the population or not? Are we looking for a proportion? We use a different, D will have a different distribution. We're using a different distribution to test. In the case that, say, we knew the standard deviation of the two original distributions, which is an unlikely situation, somewhat uncommon, but let's just start there. If we knew the standard deviations of the first two distributions of the original distributions, x1 and x2, then we can compute that the standard deviation of D is equal to the square root of the standard deviation of the first distribution squared over the sample size, right? Whatever, remember, we're taking sample means to get x1 bar and x2 bar. And we simply add this to the standard deviation squared of the second distribution over n2, the sample size for the second sample. Okay, so again, let's be clear what everything is here. The standard deviation of this new difference distribution that I call D is determined by the square root of the sum of the standard deviation of the first distribution squared divided by the sample size we took from the first distribution, and the standard deviation of the second distribution squared divided by the sample size of our second sample. Okay. In the case that our original distributions are normal, or if our sample sizes are large, D will turn out to follow a normal distribution, right, with the mean as described and the standard deviation as described, right? The mean given here and the standard deviation given there. So in that case, then we can conduct our test. We will compute a z-score, and then we can either z-score will be our test statistic, and we can either use the critical value method or compute a p-value. In the case that we don't know the standard deviation, we use a t-test, just like we did in single sample testing. And if there's a proportion, we use the z-score again. There's a few other details that we'll get into when we go through all the different types, but this is the basic premise. The big difference is that we're creating a difference distribution by taking samples and subtracting one from the other. And some of the formulas get a little more complicated because of this, like the standard deviation formula, right? It has a little extra to it, that we have to take these standard deviations and do all this stuff to it. But that stuff's not going to be done by hand anyways. And so it's really, again, just about recognizing the category that we're in and making sure we apply the right test. Okay, so in the next video, I will start with the examples and the different types of testing we'll do.